We have backed up to local disk plenty of times, but how do things change if we want to back up to a cloud? Welcome to this video on backing up SQL Server. My name is Kevin Fiesel. I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. So far in this series, I have backed up SQL Server databases to disk. In this video, I'm going to expand that horizon just a little bit and back up to Azure Blob Storage and Amazon S3. Let's briefly go to the classroom before we hit the demo. I would like to point out one thing first up, and that is backing up databases directly to S3 is a new feature in SQL Server 2022, and it will not work for prior versions of SQL Server. In prior years, what we could do was take the backups locally and then write a command to push those completed backups from local disk into a cloud provider. And to be honest, if speed is a top priority for you, you're probably going to want to keep that approach. Even so, there may be a few reasons why you might want to back up directly to a cloud provider. The first is if you are hosting a VM in that relevant cloud provider. In that case, backing up directly to S3 or Azure Blob Storage can make a lot of sense, as you won't experience as much of a storage speed penalty writing to cloud storage versus the VM. Going one step further, if you're using Azure SQL Database or Azure SQL Managed Instance, backing up to Azure Blob Storage is your only option. A third reason could be if you are very low on local disk space and you don't mind database backups being a bit slower, either because your databases aren't that large or you have something like an AWS Direct Connect or Azure Express route between your local data center and AWS or Azure respectively. In that case, it could make sense to write the backups directly. And a fourth reason is kind of tricky. When we talk about backing up to S3, what we're really talking about is backing up to S3-compatible storage. That's because AWS has a specific protocol for how S3 will behave, and that lets other companies build their own interfaces in that image. For example, Pure Storage has FlashBlade, which lets you write to their storage using the S3 protocol. That won't suffer the same performance issues, and you'll still have everything local. But let's be honest, I'm just freewheeling ideas here. I'm sure that there are other good reasons you might want to do this, and probably some bad reasons as well. I'm just here to show you how you can do it, not necessarily to justify the practice. And that statement probably gives away my bias. I would much rather have local backups first and then push them into a cloud as part of some scheduled task. But because there are good reasons why we may want to go this route, I'll show you how to do it. With that, let's go to the demo. During the demo, I will talk a little bit about the order of operations you'll need to get everything running, as well as some of the requirements and limitations around backing up databases to S3 and Azure Blob Storage. I'm starting this demo out in PowerShell. The reason for that is, although I am going to talk about backing up to S3-compatible storage, I won't actually back up to S3. Instead, I will back up to a service called MinIO, which offers a compatibility layer following the S3 API. I'll first start by confirming that I have the latest version of the MinIO container image. Of course, this requires that I have Docker installed. I'm running Docker for Desktop on Windows, but this will work fine with other containerization variants, including on macOS and Linux. Next up, I'll start a MinIO container. I'm running in PowerShell, so I need to offset each line with a backtick rather than a backslash like I would in a shell like Bash. This will start up the container and set a new persistent volume that runs on my D drive and will write out files to minio/data. I'm also specifying what the root username and password will be for the service so that I know my login credentials. This is running on ports 9000 and 9001. Port 9000 is the API port and 9001 is the UI port. I want to note that there are two addresses. The first is on 127.0.0.1, which is my local host. The second is a 172.17 address, which is my Docker internal network. I am going to need both of these IP addresses for later. Let's hop into a browser and navigate to port 9001. I'll need to log in, so let me enter root user as the username, following that up with my password. Assuming all goes well, I'm now checking out the object browser, but I have no buckets. S3 has this notion of buckets, and that is logical containers that keep data separate. MinIO represents buckets as folders on your file system. I'll create a bucket and name it Backups. Note that there are some limitations around what you can name your bucket, and MinIO helpfully provides a list of bucket naming rules here. My name fits all of these rules, so I'll select Create Bucket and make it available. Now that I have a bucket, I also want an access key for SQL Server to use, so I will navigate to the Access Keys page and select Create Access Key. It auto-generates a reasonably strong access key and secret key. I'll set the name to SQL Backups and then select Create. This gives me a screen with the access key and secret key in plain text, so let me copy and paste these into Notepad before I close this window. That way I'll be able to use them once I get to SQL Server. The next thing that I need to do is create a self-signed certificate for MinIO and put it in my trusted certificates list on Windows. By the way, I am indebted to a pair of blog posts from Anthony Nocentino for this S3 portion of the video, as Anthony has done the hard work and I'm just riding on his coattails. I'm going to open up a new terminal window, this time using Windows Subsystem for Linux. I've already got that installed and configured, and it will make generating the self-signed certificate that much easier. In a production environment, you wouldn't do this, of course. You would get an actual self-signed certificate and deploy. Or really, you'd actually upload to Amazon S3 rather than a local S3-compatible system like I'm using, unless you have something like the Flash Array, in which case, well, you're still doing this. Inside of here, I'll navigate to /mnt/d/temp, which is a junk drawer directory on my D drive. Then I'm going to paste in a command to create a new file called openssl.cnf. In it, I'm defining s3.localhost, which is what I intend to use later on when connecting via SQL Server. The first IP address binds the cert to localhost, and the second one binds it to the Docker container address. Let's run the command, and it will create a file called openssl.cnf. Next, I'll run the openSSL command to create a private key and a public certificate in the same directory. After that, I'll copy the private certificate to the Docker container. By the way, I can check which container I intend to use via Docker PS. I can see that the name of this container is MinIO1. Let's copy the private key and then the public cert as well to the root certificates directory, and after that, I will restart the container. Both of those copied without a hitch, and restarting the container allowed MinIO to take the new certificate. The next step is for me to add a trusted certificate to Windows. To do so, I'll open the Start menu and type in CERT. I can see an entry for Manage Computer Certificates, which I'll select. That will lead to a UAC prompt, so as soon as I approve the UAC prompt, I should get a certificates list. Let me drag it over and make it available for you to see as well, dear viewer. Inside of the certificates list, I'll navigate into Trusted Root Certification Authorities and then Certificates. I can see all of the root certs here. I'll right-click and from All Tasks, choose Import. From there, I'll select Next. This brings me to a file selection menu, so let me paste in the location of the public certificate. I'll place it in the Trusted Root Store and then select Next. Finally, I can finish the job and let importation complete. And if I check the list, I do see a certificate for s3.localhost. All right, that's done. So we have the means to do what we need to do. Now it's time to move to SSMS. In SQL Server Management Studio, I am going to start off by creating a credential. I'll need to replace the access key and secret key bits with my actual values. Note that a colon separates the access key from the secret key. Next up, we want to back up a database. I will start with a small one, analyzing biz data. As a quick note, I'm actually referencing localhost rather than s3.localhost here. I will still use the s3.localhost certificate, but now I don't need to set up any routing rules or anything like that. The main change from any other backup is that I am backing up to URL instead of disk. Now let's talk about a couple of these settings before I kick off the backup. The first is with format and with init. We learned in a prior video that with init will overwrite any backup information already loaded in the file. Meanwhile, with format creates a new media set in SQL Server. When backing up to S3 or Blob Storage, you must run with format and with init. We define the media name and the backup set name the same as before, so nothing has changed there. I can decide whether to compress the backup or not, as well as whether I wish to encrypt it. Neither of those settings change when backing up to S3. Similarly, I can still perform a checksum and take a copy-only backup. Basically, the major thing that has changed so far is that I absolutely must have with format and with init. If you try to specify either no format or no init, you will get an error that clearly tells you the problem so that you can fix it. Let me briefly show you what the results look like in min.io. I'm in the data folder and can drill into backups. Inside of here, I see analyzing bizdata.back as a folder. Inside of this folder is a binary file with metadata about the contents of the folder, as well as a subfolder with a GUID for the name. Inside of the subfolder, I see part.1, and that contains the entire backup. Let's double check that restoration in this simple case is the same as before. Back in SQL Server Management Studio, I will paste in a new script. The restore script here specifies the URL, and I'm going to restore to a new database, analyzing bizdata2. Let's run this script, and we can see that it successfully restores the backup file. Great. Now let's try a more interesting scenario. I'll kick off a backup of the Chicago parking tickets database. This database will add up to approximately 16 gigabytes of backup data. This means it's going to take a little bit of time to write, so I'm going to need to vamp while it does so. In the prior video, we did time this backup writing to disk in approximately 16 seconds, going to a direct attached NVMe drive. This run through, however, is going to take a fair amount longer because we're pushing through the S3 protocol. In fact, I'm now going to ask my editor to speed us through this because look, I don't actually have the time to wait. Okay, we're done. And it took significantly longer than 16 seconds to complete this time around. In my test run through of this, it took me approximately 3.5 minutes to complete and wrote about 78 megabytes per second. And let me show you why. Back in the backups directory, I'll make sure that I can see Chicago parking tickets.back. Inside of there, I'll navigate to the subdirectory and we can see 3,275 files in this folder, each of which is exactly 5 megabytes in size, except for the last one. We wrote out all of these 5 megabyte files. But how? Well, this is one of the key differences between S3 and every other mechanism for backup. S3 has a limit on the size of any file part. By default, SQL Server breaks up the backup file into chunks. In this case, it broke it into 5 megabyte chunks, but we can control that. And by the way, the documentation says that the default value for this chunk size is 10 megabytes, but we can see here that it definitely wrote out 5 megabyte chunks and I used the defaults. So I'm not sure if that's an issue in the documentation or if there are specific circumstances where it might write out 10 versus 5. In fact, if you watch the prior video in this series, you already have the right tools to figure out how we can set the chunk size. SQL Server uses max transfer size to determine how to split apart those file chunks. In the prior video, we talked about how valid values for max transfer size range from 64 kilobytes up to 4 megabytes. But for S3, the ranges are a little different, from 5 megabytes to 20 megabytes. The documentation says that you can change the max transfer size, but you do need to enable compression. I have found in my testing, that's not actually the case. But for the purpose of not taking too long waiting for backups in this video, I will skip the demonstration and simply state for the record that I could change the max transfer size to 20 megabytes without enabling compression, and it generated 16 gigabytes worth of backup data, which is the size of the uncompressed backup. That backup, by the way, took about 1 minute. So increasing the max transfer size to 20 megabytes from 5 megabytes was enough to cut the backup time to a third in my scenario running min.io on a local container on direct attached NVMe storage. Now let's try a compressed backup and specify the buffer count. Let me run this and then talk about the query. With regular storage, either direct attached or via SAN, we optimize for the value of max transfer size times buffer count. I was happy with approximately 128 megabytes of RAM used as the total buffer size. So I'm going to replicate that here by using 20 megabyte max transfer size and 7 buffers. That adds up to 140 instead of 128, but it's close enough. I am also going to enable compression. With settings like these, it took approximately 5 seconds to back up the database to disk. With backup to S3-compatible storage, it is going to take closer to 30 seconds to complete. This is a big part of why I highly prefer backing up to local storage first. Then, if you want to keep the backups in S3 or Blob Storage, you can do that via separate script and not need to worry about long backup times. Anyhow, the backup has completed by now, so let's check it out. I'll navigate back to the Chicago Parking Tickets.back folder and drill in further. Now I have 408 items, almost all of which are 20 megabytes in size. This adds up to 8 gigabytes, which is correct for the compressed backup size for Chicago parking tickets. Okay, now let's do the same thing for Azure Blob Storage. This time, instead of backing up to a local container via min.io, I will back up directly to Blob Storage, as I do have a storage account I can use. I'll start by opening a new query window so that we have a fresh start. Next, I'll need to create a database scoped credential. In the S3-compatible storage example, I created an access key and used that as my secret. For Azure Blob Storage, we typically follow a different pattern, and that is to create a shared access signature, or SAS, token. One of the easiest ways to do this is to use Microsoft Azure Storage Explorer, which is freely available. For today, I'll drill into my Visual Studio Enterprise subscription and then drill into CS Polybase Blob. Inside of here, I have a blob container called Backup, and I'd like to use that for storing my SQL Server backups. Let's right-click on the container and choose Get Shared Access Signature. Each SAS token has a start time and an expiry time. The default is to create one that lasts for 24 hours, though you can control the length of time. In an enterprise scenario, you would typically have some service that generates new SAS tokens on a frequent basis. If you want more of a set it and forget it approach, and you're willing to accept the minor security risk of having a SAS token hanging around for a while, well, you can create that SAS token with a longer expiration time, but now you have to maintain it. You have to make sure you don't check it into source control. You have to make sure that it doesn't get into the hands of an attacker. In the permissions box, there are 9 separate permissions. We are going to need read, write, and list. We can use the add permission to append to an existing blob, and create allows us to create a blob but not append to it. But write will cover both of these scenarios. Read allows us to retrieve data for a given blob, and list allows us to retrieve information on what blobs exist in a container. We do not need the delete permission, as write will allow us to overwrite files with the same name should we wish to do so. I'll select the Create button and generate that SAS token. Notice that both boxes here contain the SAS token. I'll copy the URL and take the SAS token from it later. Back in SSMS, let's fill in the database scoped credential. I'll start with the template that I need. Note that the credential name has to match the URL to my container on my storage account. So this is going to be CS Polybase Blob Storage account and the backup container. I'll paste in the SAS token as the secret here and then create this credential. Now I'm ready to take some backups. So let's jump straight to Chicago parking tickets. I'll first kick off this query and then I'll explain it. First, our URL is the storage account and the container name, followed by the backup I want to create. My max transfer size is back to 1 megabyte. The reason for this is Blob Storage doesn't break up files into parts like S3 does, so we're going back to the normal rules for how it and buffer count work. I'm compressing this backup and setting the stats to show every 10% of the backup that we've processed. This is going to take a little while to complete. In my test run through, it took just shy of a minute to complete, so that's a fair amount of vamping that I'm going to need to do. Which means I will now tell you about some limitations before we move on. There are 2 types of blobs that you can write SQL Server database backups to using Azure Blob Storage. The first is page blobs, and the second is block blobs. I highly recommend you back up to block blobs because you can use SAS tokens, you can back up to multiple block blobs, it is cheaper, and it's the only option that's available if you're using SQL Server on Linux. Also, you can upload a database backup of up to 1 terabyte if you're using a page blob, but you can stripe up to 12.8 terabytes per upload with block blobs. In short, use block blobs, even if it's difficult for me to pronounce. And it also happens to be the default blob type for containers, so you don't even need to do anything special here. Okay, the backup has completed, and let's see what we have. If I refresh the screen here in Microsoft Azure Storage Explorer, we can see the Chicago parking tickets database backup as a single file of nearly 8 gigabytes in size. I could hold that file in here as long as I'd like and use it as a less expensive long-term storage versus the fast and expensive local disk or all-flash array that I'd like to have for SQL Server. And the last thing that I'll show here is how to restore a database from Azure Blob Storage. Let me run this script and describe it while I'm running it. This script takes the blob from Azure Blob Storage as the URL. Then we're restoring to a new database, Chicago Parking Tickets 2. We can see that the move commands are the same as with any prior backup, where I switch the Chicago Parking Tickets data and log files to my local disk. Other than the original file coming from a URL, there's really nothing different here. And I can even have multiple files from multiple URLs, just like I could have multiple files reading from disk. So for this reason, I'm not going to belabor the point, and instead, let's just cut straight to the outro. And that'll do it for this video. I covered a lot of the story around backing up to S3 and Azure Blob Storage, though I do highly encourage you to read the linked articles and blog posts in the description below, as they do contain some additional caveats and details that I didn't get to here. In the next video, we'll take a peek at how we can back up and restore individual file groups. We'll have links and show notes in the description below, and until we see each other in the next video, take care.